isn't this nice? A real, honest-to-goodness live event. Yay! Well done, Charlie and Tabitha, for organising this and all their many excellent helpers. Fantastic. Now, Daniel, I can't overstate what a pleasure it is to have this conversation with you. You are one of the pivotal people at CogX ever since it got started, but I think there might be one or two people in the back who don't know exactly who you are. So give us the elevator pitch bio of Daniel.
Great. If they don't know who I am, I can make something up. So I do three things. I'm the entrepreneur in residence for UCL Computer Science. So I help them take deep technology from computer science engineering and figure out how to create impact from that technology. And for 4 or 5 years, ran a master's program in applied AI at UCL. So I had about 50 students every year go out there, apply emerging technologies to solving problems across a whole range of different industries. So I've got a very good sense about where companies are at in their digital transformation and applying these technologies. And my entire academic background over the past 20 years is in artificial intelligence, from my undergraduate, my master's, my postdocs, my PhDs. So I wear an academic hat, and but my day job is running a company called Satalia, which is about 120 people distributed across Europe, and we build AI solutions for some of the biggest companies in the world. And the third thing I do, a lot like Calum, is I get to historically travel the world educating politicians, academics, industry leaders about the impact of technology on society. We do it from the comfort of our own home. It is nice to be out, I have to say.
Very classic Daniel to slide in the middle there, the fact that he founded and runs what I think is probably London's biggest independent AI consultancy. So, Daniel, tell us a bit more about Satalia. What is Satalia? What kind of services does it offer?
Yeah, so Satalia span out of UCL 12 years ago now. During my PhD, I was frustrated. Well, actually, originally my PhD was to model the brain of a bumblebee. Bumblebees have 1 million neurons, and they can do amazing things. They fly around 3D worlds, they talk to each other, they solve problems, they don't handle windows very well, but ultimately they're very smart creatures. And the question 15 years ago was, can you take the brain of a bumblebee and put it into a machine? And 15 years ago, it was too difficult to do that. Now we have deep learning, and we can model hundreds of millions of neurons. But I got interested in a subject of which is optimization. So machine learning is very good at finding patterns from data. Deep learning, very good at finding patterns from data. But deep learning is typically not very good at making decisions. And decision making is a completely different field in computer science. Used to be called operations research, probably going to be called decision science because it sounds cool. But optimization, operations research is something I've become very passionate about, and realize there's tons of algorithms that sit in academia that solve decision problems, and those algorithms don't have a conduit into industry, and those algorithms actually, I believe, the ones that really will make a big impact on industry. So 12 years ago, I thought about creating an API, essentially, that people could submit optimization problems to, and we would use machine learning to identify what are the right optimization algorithms to apply to these problems, so that you're then unlocking this incredible creative capacity of academics. 12 years ago, this was before the cloud, before APIs, before any of that stuff, so it was very, very early. And it's still early now, if I'm being really honest. And for the first 5 years of the company, I was just looking for any opportunity to apply machine learning optimization to solving problems in industry. So solve problems from network planning to people rostering across a whole range of different companies. And then we essentially had our big break 5 or 6 years ago from Tesco, which I guess we'll talk about later on. And that gave us the revenues to be able to then grow the organization. We've never taken capital, so we've grown organically over the past 12 years, and it's really in the past 6 years have we really started to accelerate.
And have we modelled a bumblebee yet?
I think that I don't know where we're at, but I think that we probably have modelled fruit fly brains, but physical brains, they have spiking neurons which operate very differently to artificial neurons, and so there's a huge amount of complexities there creating these parallels. But I guess the breakthrough with deep learning is that we're able to parallelize the learning, the compute on GPUs, which means that we can now build very big brains. We can train those brains very, very quickly, and we can get those brains to do things that humans can do, which is one definition of AI. I think that it's a weak definition, and we'll talk more about, I guess, the AI definitions later on. But deep learning, as I said, is very good at doing one thing, which is finding patterns in data. It's not good at making decisions. And actually, I would argue that companies don't have machine learning problems. They have decision problems.
We will get to that. Yeah. So we're going to spend 24 minutes or so talking about delivery AI and delivery businesses. And then everybody here is going to get a chance to ask Daniel some difficult questions. So be brewing your difficult questions. Before we start on delivery, one thing that I know is very important to you, and indeed to me, is decentralization. And you're working on that and actually walking the walk in Satalia in some interesting ways. Do you want to talk a little bit about that?
Yeah, so as I mentioned, Satalia, one of the things that Satalia does is we apply machine learning, optimization, these technologies to building innovations for companies, and then those companies tend to then internalize those innovations, internalize those products, and then we move on to the next problem. We also do another thing, which is we productize. So we've taken some of the innovations that we've built for organizations like Tesco, like PwC, and we've created. Product is probably too strong of a word. They are assets that can be deployed very, very quickly for organizations. So we have logistics assets, and that's been rolled out across Woolworths in Australia that do grocery delivery. We've got assets in workforce planning, optimization that we've developed for PwC. Anyway, the second thing that Satalia does is have these products. But I actually want Satalia to be essentially a venture builder. I want to be able to create innovations for organizations, get those innovations to scale very, very quickly and have a positive impact on the world. We're not just one product company, we want to be a portfolio of products. And whether that means giving them away, whether it means open sourcing them, whether it means getting investment and selling them, I sort of don't mind. I just want to take deep tech and get them scaled into industry. And if you look at how organizations operate, most of them are either good at either being a services company or a product company, and it's very hard to find companies that are exceptional at both. And one of the interesting challenges that I have is how do we become exceptional at product and service and spinning out new companies, and that means asking yourself, how should you be structured as a company? So I often get challenged that Satalia is trying to operate like a swarm. We have people that want to boot up ideas and then swarm around those ideas to get them to the point where we might be able to take them to market. But actually, that's not the case. I'm not trying to create a swarm company. I'm trying to create a platform that allows people to boot up ideas, swarm around those ideas, and then take those ideas to market. But I'm not wedded to the idea of operating like a swarm. Let me explain that a little bit better. So if a product needs to get taken to market very, very quickly, you might have to operate as a hierarchy. If you need to spend some more creativity, get more diverse views in trying to solve problems, you might need to operate like a swarm. What I'm trying to do is create a platform that allows for creation of frictionless innovations. And I want to actually not just make that work for 120 people, I want to make it work for a planet. I want to try and create a world where everybody is born into this world, can create ideas and can swarm around those ideas and get them to market very quickly. I actually want to create a world without companies and without countries. And the best case scenario for Satalia is actually not to have a company at all. I want to unlock the creative capacity of everybody in society to be able to create innovations and scale them to market. So and we're trying to solve many of those challenging problems inside Satalia that we might productize or give away.
I can hear the strains of John Lennon's Imagine
yes,
surging
one of my favorite songs.
You're walking the walk in some interesting ways in Satalia, the way you get feedback from all your people about each other. Tell us a little bit about that.
So the hypothesis is that you need to tap into people who are closest to the problems to be able to make decisions. And I think we're all on board with that. But the way that organizationals work at the moment is that they're hierarchies. You've got layers of managerial structures and processes. And it's often the case that you have decisions being made that are not necessarily right or by people that have all the information. So what we try to do is use machine learning to essentially create digital twins of our company. We create these maps where we understand people's skills, their relationships between each other. So one of the crazy things that we used to do that we've changed now is we used to get everybody to make public recommendations for their salary. So everybody would publicly declare what they want to be paid, and then people would then vote on whether those salaries should be reduced or increased or kept the same. And we use machine learning to determine how many votes one person has for another. And so if you've worked very closely with that person, if you're very knowledgeable about their domain, you'll have more votes for their salary than other people. Now, as it happens, people are rubbish at making recommendations for their salary, but you can still apply that principle, this decentralized decision making platform structure, to making decisions about feedback, about resourcing people, about hiring or firing people. And that's the principle of this platform, is how do you decentralize decisions so that you're making decision making as efficient as possible.
Yeah, fascinating stuff. So several years ago, you meet Tesco and they've got a problem. What was their problem?
So Tesco at the time brought on quite a few people from Amazon, and Amazon's attitude historically has been we need to build an own IP that we have, and Tesco, like many other companies, are depending upon third-party products, software to do core things like last mile delivery. So when you go to the Tesco website and you fill up your basket and you say, show me the slots, and you click on a slot, and then hopefully that driver comes and brings your groceries, that's essentially called last mile delivery. And there are loads and loads of tools out there, software out there that do that. Tesco realized that this was a core piece of technology that they needed to develop internally. They didn't necessarily have the talent back then to do that, so they went to market and they looked for organizations that could help them. They knew, like a lot of large organizations that have a very sophisticated supply chain, they knew that this is an optimization problem. This is not a machine learning problem. This is a decision problem. How do I allocate my vehicles in a way that's maximizing my number of deliveries? And so they chose us because of our pedigree in optimization. Now, as it happens, we combined optimization and delivery, and machine learning. But we over the course of several years worked with Tesco to build for them a last mile delivery solution from zero, and that was actually a massive challenge because many of the people that were competing within the market had already invested millions of dollars. They've been around for 20 years, and the question was, could you now do something that's differentiated and beating these people? Actually, after 6 months, by utilizing bleeding edge algorithms from academia, by deploying it on the cloud, we were already beating state of the art. And then the next challenge is, how do you then get users using it, and how do you then roll that out across an organization that has hundreds of stores, thousands and thousands of vehicles? And that's actually been the thing that takes the most amount of time. And then we've internalized that in Tesco. So Tesco now bring that internally. They'd have their own teams of people driving those innovations. Actually, off the back of that, we developed our own logistics solution that we've now taken to market. But that was the process with Tesco. And actually, we've continued our engagement with Tesco, looking at other parts of their supply chain, solving big, challenging problems, which maybe we'll be able to talk about next year in CogX.
Look forward to that. Was it a brave decision for Tesco to hire you? Because you weren't a big company, and of course, you don't get fired for hiring IBM or PwC or Accenture. Was it a rather ballsy decision for Tesco? It
was incredibly brave, and I have a massive respect for them, because the easy decision would have been to go with a company. We had zero expertise in logistics, no expertise. In some respects, that's a double-edged sword. We can come to things in a way that doesn't have any predetermined restrictions, and I'll give you an example of that now. But at the same time, we had no experience in logistics. So by bringing our teams together with their team, who have a deep understanding of logistics, we were able to create these innovations. And I guess one of the first hypotheses that we tested was, maybe I could give you some maths, but when you go to Tesco's website and you fill your basket and you click on show me the slots, you have 1 second to figure out how many slots do I have, can I show this customer. 1 second. And historically, what would happen is that the tools that they would be using would have predefined slots. So you would say, I'm pretty sure that I can fulfill 1,000 slots at 9 a.m., 2,000 slots at 10 a.m., 3,000 slots at 11 a.m. And that those would be predefined slots. And you would fill those slots. And in the background, you'd try and figure out, how do I make sure I can fulfill these slots? We didn't know that it was impossible to do that dynamically. And what I mean by that is, when you click on that show me the slots, we assumed that we could figure out precisely how many slots we could show those customers that we can guarantee to fulfill. Now, because we didn't know it was impossible, we solved that problem, and which is a huge innovation. So maybe just to break that problem down, is that imagine you've got your schedule planned, your current schedule, that you've got people, vehicles delivering to various different customers within an area. A new customer comes in, fills up their basket, and now says, show me the slots. So the first thing you have to do is get the current schedule. The next thing you have to do is calculate how long does it take to get from every single person in this schedule to this new place and back again. So you have to create what is called a travel matrix. You've got about 250 milliseconds to do that. And then you have to figure out, how many slots can I show this customer? So can I have it so that I can deliver to this customer at 9 a.m., 10 a.m., 11 a.m. over a 7-day period? That has to happen in about 500 milliseconds, and then the 250 milliseconds are talking to various APIs. Again, because we didn't know that was impossible, we solved that problem. And the key innovation there is not the algorithm that's trying to figure out the slots at 500 milliseconds, trying to figure out, can I deliver at 9 a.m., 10, 11? There are lots of algorithms that have been developed in academia that have been published that can do that quite well. The key innovation was figuring out how to make this how to create this travel matrix in 250 milliseconds. And if you go and ask Google's API, give me 3,000 A to B points, it'll take several minutes to calculate 3,000 A to B points. We have to do that in 250 milliseconds, and that is what we call our routing engine. It's calculating how long it is to get from A to B, and you have to do that extremely accurately. A lot of tools on the market will do crow's flight. So I'm living in this address here. I've got another customer over here. Let's just do a crow's flight plus some sort of kind of wiggle hack. We actually had to calculate that precisely. So, and that's one of the core innovations. So I forgot your question, Callum. I went on one, but
no, yeah. I think you answered the question.
So why they chose us, it was because we had a deep pedigree in optimization. We brought those algorithms to Tesco, but we also had this very interesting routing challenge to solve. And because we didn't know what was impossible, we solved it.
Excellent. So ignorance is the mother of invention.
Indeed.
I think that's very plausible. You talk about the difference between optimization and machine learning, or the new form of AI. Talk a little bit more about that. Where is one suitable and the other suitable, and do we need to increasingly merge them, or are they going to remain as two separate disciplines? So
there are people at the moment that are trying to apply deep learning to solving optimization problems, and I think that there's some weight in that. We have some people that are starting PhDs in trying to work out, could we get deep learning brains to come up with algorithms that can solve optimization problems. But there's already 5 decades of research in solving optimization problems, so I think it'll be hard to compete with them right now. But so optimization is about decision making, and actually in logistics there are 4 optimization problems to solve in this last mile delivery. So the first optimization problem is, how many slots can I show that customer? And that has to happen in 500 milliseconds. The next optimization problem is between this customer and the next customer coming in, you might have a few milliseconds or you might have a few seconds, particularly in Tesco's case. So how can I now optimize those vehicles in the background as much as possible, so that when the next customer comes in, I can show them as many slots as possible? So you've got a few seconds to do some rapid optimization. Another one is, sometimes depots go down. Sometimes you have mass problems where you have to very, very quickly reschedule loads of deliveries, and you have to do that quickly so you can start fulfilling slots to your customers. That's a different type of optimization problem. And then the fourth one is between cutoff and loading your vehicles. So at night, when you're stopping showing slots to customers, which is what you're trying to maximize during the day, at night, what you want to do is actually, you might want to balance now deliveries across vehicles. You want to make sure that your vehicles are not leaving all at the same time, so you're not creating bottlenecks, or coming back at the same time, so you're not creating bottlenecks. So this kind of post cutoff optimization is your solving for a different type of problem. And again, you might have 15 minutes, an hour, which again, you can apply a different type of optimization algorithm. Now, even more complex in this is that during the day, as you're building your schedules, you know, initially when you start out, you have no customers, and as your schedules build during the day, that the shape of the problem changes, and it certainly is different for urban type environments versus rural type environments. And so you've got loads of parameters that you could be adjusting as the shape of your schedules change. So, and that's also an optimization problem, but you can apply machine learning to changing those parameters. So there are 4 key optimization problems. There's a whole load of routing algorithms that you need to develop to be able to calculate how long it takes to get from A to B. And that sort of sits between optimization and data science. It's actually graph theory. And we've built some innovations in that area. And that is an area that really does need to be innovated. And then finally, you can use machine learning to do things like predicting how long is it going to take to deliver to this customer. I think 50% of the schedules for some of our companies one of our customers is DFS. They deliver sofas to people across the UK. 50% of the schedule is how long does it take to deliver that sofa? Because it might take 10 minutes because you just hand over a chair, or it might take 3 hours because you have to take the window out because you can't get the sofa through the door. So that's where machine learning is very good. So it's predicting how long it takes to do these things. So this is where you need to combine these three types of technology: decision making optimization, graph theory for routing, and then machine learning for making predictions. So how long will it take? Maybe I can give you some examples from DFS. We were using machine learning to try to profile driver behavior. And it turned out that you could identify, this was anonymized, but you could identify drivers that were having a cup of tea with the customer after they've delivered the sofa. You could identify drivers that might be having a cigarette after they've delivered their sofa. And actually it has an impact on Net Promoter Score. So if you have that driver having a cup of tea with the customer, it might increase Net Promoter Score because it might be a very nice chat. Some drivers you might not want to encourage having a cup of tea with customers, but you can use machine learning to like profile the behavior of drivers, whether some drivers are slow at driving versus faster delivering, and then you can start to build your schedules around that. So that's where machine learning can really play. So often I see companies applying machine learning to solving all their problems, and it's the wrong thing to do. Companies for the past 5 years have been hiring my students who are data scientists to solve decision problems. Companies don't have don't have machine learning problems, they have the decision problems, and that's a different set of skills. I can't emphasize that enough. So
the people who say that reinforcement learning, machine learning systems can get us all the way to AGI on their own, that they're wrong. They're going to need the other disciplines as well. I think it will be hard for the time being for an AGI to solve optimization problems as well as the algorithms that we currently have. But and I don't think they will solve them directly. I think what will happen is we'll create AGI to create new optimization algorithms that then solve these problems. I don't know if that makes sense. I don't. It won't be a direct mapping. Cool. And what's the state of the art with, say, grocery delivery platforms now? I know you have some interesting thoughts about how Tesco and others could defend themselves against the entry into the market of Amazon, who've signaled very strongly that they're going to take this market very seriously. And of course, they've got the very hard to combat business model that they don't have to make profits. So you've got some ideas about how Tesco and others could defend themselves. Indeed, it's hard for organizations to compete with companies that essentially don't need to make money. Right? Let's assume that Amazon and Google and these are the companies that have deep pockets, and if they wanted to go into a particular industry, they can undercut that market, even if they don't have as good a technology, even if the solutions is not as good, but they can go in and provide free deliveries and all of this kind of stuff and undercut that market, taking their users. Whereas companies like Tesco have to answer to the market, and they have to provide their shareholder returns. So the question that you have to ask yourself is, how does a company compete with another company that doesn't have to make money? And the answer to that, I think, is you can't. And so I think what you have to do is change the nature of a company. And but one of the things that you could do if you were a Tesco is protect yourself by actually giving your solution away. And I know that sounds crazy, but if you open sourced your logistics solution, and three things will happen. What will happen. One is that you might be able to tap into more people globally to innovate that product, which is great. It benefits you, because a lot of these organizations don't have people still innovating those products. They've gone and focused on other more exciting projects. So the first thing by open sourcing it or something like that is that you can tap into a community of people that are going to drive forwards that product, and you need to create an incentive mechanism to do that, and that might be paying them or whatever. The second is if you are the ones that are open sourcing that tool, you're most likely the ones that are getting access to data, and that data is incredibly valuable. So you're collecting the routing data, you're collecting drive times, and that data is mega valuable. And it might be that eventually you have to open source that data or put it on a blockchain, but having that data will be a competitive advantage in the medium term. The third thing as well is that Amazon then it doesn't make sense for Amazon to build a team of 30 people to build a logistics solution, because you now have a team of 3,000 people potentially globally that are building out this open source delivery solution. So I actually encourage my clients to think about open sourcing their tools, because it whilst it does commoditize them, it potentially gives them an advantage in the medium term. And actually DFS is one of our favorite clients, and what we're helping them do
is take the infrastructure that we've been building for them. So we've been building last mile solutions, middle mile solutions, warehousing, manufacturing. We allocate staff in their stores. We predict demand in their stores and then allocate staff optimally. One of the things that we're doing with DFS is actually turning that infrastructure into a platform. So DFS have just created a company called the Sofa Delivery Company, and they will be becoming the Ocado for sofa delivery. And that's one of the other ways that organizations can potentially compete against the Amazons and Facebooks by platformizing their innovations, and that's what DFS will be doing.
And what's the conversation like when you say to Tesco, "Hey, why don't you share your platform with Sainsbury's?"
Yes, it's usually it's
brief.
Do you know what? Like in many organizations, are incredibly forward thinkers and whatnot, and they get it. The challenge is how these organizations are structured and whether you have the resources to be able to do that. That's
sure.
You know.
So DFS, I know there's a really great story about Scotland. Tell the DFS Scotland story.
Yeah, so that's another example where in a lot of these systems you'll have these default settings. So with DFS, I think that they just said every single delivery takes 30 minutes. Now, of course, it doesn't. Some deliveries take 4 minutes. Some deliveries take 3 hours. I think in the Scotland case, it was 20 minutes, right? And I don't know why it was 20 minutes versus 30 minutes, but because they had 20 minutes, they just made it happen, right? It's people just did 20 minutes. As it happens, we're a lot smarter now about making predictions about those delivery times, so we know if it is going to be 4 minutes or 4 hours to make much more accurate schedules. But that was an example where there are assumptions that are built into these systems that you can start challenging using AI.
Yeah, I understand it was a mystery for quite a long time. How was Scotland getting their deliveries done quicker? Do they have fewer stairs? Do they have bigger, beefier delivery people? And it turned out it was just that the Scots had decided to be quicker.
Yeah, indeed.
So they were. Yeah. Before we open it up to questions, I know that you're very keen on decentralization, partly because it's important to decentralize and get delivery businesses as efficient as possible in order to enable the economy of abundance. I mean, you and I both belong to a think tank which believes that technological unemployment is coming in some decades in the future. And if we get delivery as well as production as efficient as possible, we can have the economy of abundance, which means that can be a great world rather than the problem. Are you confident? Can we get delivery maximally efficient so it's almost costless?
Yes, absolutely. And so maybe just to kind of expand on that, the aspiration of the next 30, 40 years is to bring the cost down of innovation so much that they become almost free. And potentially we can create a world where nutrition and healthcare and education and all of these things that we depend on become almost free. And that might help us take the edge off where people can't work because they don't have jobs. And of course, if you let's say we were able to use AI to create to do agriculture, to create nutrition, and then the challenge is how do we get those goods to people, and logistics is an incredibly important part of that. As you can all imagine, across humans, it requires a huge amount of energy. So that's why I'm very excited about solving problems that have a physical impact on the world, and I think that one of the things that Satalia might do is take our logistics solution, which we believe is bleeding edge, and actually open source it so that we can tap into the creative capacity of everybody to make it as efficient as possible. Now that does two things. One is it means that logistics solution is available to everybody in the world to utilize, whether you're routing ambulances or whatever, and you don't have to spend millions of pounds building it, or if you have to spend millions of pounds on licenses. And the second thing is it can provide people with work. If people are contributing to this platform, we can actually pay them for that contribution. But logistics is going to be an incredibly important part to create a world of abundance.
Yeah. And we need to effect a real big culture shift away from the idea that a future where we all have to be wage slaves forever is the only acceptable future, and the idea that a post-jobs world is pessimistic. We need to get a shift to the idea that a post-jobs world where we don't have to be wage slaves anymore, that is optimistic. And the people who think we have to be wage slaves forever, they are the true pessimists.
That's it. Well, maybe just to comment on that, Calum. So in a decentralized world, the idea is that if we were able to bring the cost down of most goods, that people wouldn't have to necessarily worry about having an income because those goods would be abundant, they would be available to everybody, but there would be an opportunity for people to come up with ideas. There'd be an opportunity for people to contribute to things. And then actually, if you ask most human beings, what would you do if you didn't have to work? Most of them will say, well, I'll go traveling and all that kind of stuff. But a lot of them will say, I want to help other people. I want to try and make the world better. And that's actually the promise of the economy of abundance.
Yep. And at your suggestion, I tweeted a poll about that this morning.
Yeah.
Okay, so we have reached the fabulous time in which you all get to ask questions.
You mentioned about kind of looking at driver behavior and creating kind of driver profiles in the delivery optimization process. Do you, or should there be kind of limits or restrictions or guidelines in terms of making that a slippery road?
100%. And so this is again something we're going to hear more and more of, this concept of digital twins. So digital. So if you imagine in your business, you have a lot of organizations have supply chains, and historically you've bought software to solve problems across that supply chain, whether it be warehousing or manufacturing or last mile delivery or whatever. So but organizations realize that these are essentially point solutions that are optimizing for that very specific domain. And so what a digital twin is it's a layer on top of that brings and orchestrates all of that data together. And a digital twin is a digital representation of the physical world, which means understanding driver behavior. So in my company, our digital twin, I can identify what skills people have. I can identify relationships, but it does raise a lot of ethical questions. So, for example, in my company, I can identify. I think IBM did this. That you can identify people who are going to leave the company before they know they're going to leave the company, and you can identify secret lovers in the company. You can see. I won't tell you some of those stories about drivers, but yes, you can identify lots of interesting behaviors. And the question is, should you have access to that information? So there are some very interesting ethical questions that are raised because of this, and GDPR and other regulations are going to have to catch up with the power that we now have with AI and machine learning to get visibility into these types of behaviors. Callum, I wonder if you've got an opinion about any of that. I don't know.
No, I think that covers it.
Oh.
And I've had my turn anyway. It's time for the good people here. There's a lady here. Any other hands to go up for later? Okay, one here anyway, and then this gentleman here.
I have some questions on the iPad as well.
But people here first, sure.
In real.
Good stuff. Well, thank you. It's incredibly inspiring so far hearing what you're talking about. But so I would love to live in your utopia, abundance and open source. That sounds fantastic. But a rather prosaic and potentially boring question: how do you guys make money?
Yeah. So you said there's another word that's better than utopia, which is
Yeah. Well, slightly different question, but let's do that. Yeah. The idea of utopia is problematic because it's got two problems. One is it's impossible, and the other is it's very boring because it's static. And Kevin Kelly came up with a brilliant word, which is protopia, to set up as a contrast to dystopia. And the idea of protopia is it's a world in which everything is really, really great, but it just keeps getting better. And I really like that idea. Now, how do you get a protopia, in which we don't have jobs, therefore we don't have income? There's essentially two answers. As Daniel said, you need to get the prices of everything you need for a really good standard of living. Let's say a really good American middle-class standard of living down almost to zero. Not quite to zero, because you want to retain the market, because the market is the best mechanism we have for allocating scarce resources, and there are always going to be some resources which are scarce. So you get prices down really, really low, and then there's no getting away from the fact you have to have an economic transfer from the people with assets, people and organizations with assets, to those without. How that happens, we don't know. We're working on that. But I'm sure it's possible. This last year has been a very interesting example of how something quite like universal basic income has been possible temporarily. We can't do it at the moment with the economy as it is for a long time because it makes us go broke and our children are in hock forever. But if we can get the prices of everything down close to zero, it'll be possible, we believe. We've got to work out the details. But we'll see you there.
Cool. Yeah, I look forward to the protopia.
So maybe to answer your specific question about how we make money. So Satalia has a set of skills I think we're very lucky to have, that they're valuable currently. Maybe maybe people that are very good at mathematics were not so valuable 3,000 years ago. But fortunately, we're living in a time where that is valued by organizations. And the nature of optimization problems is that, and until we solve what is called the P versus NP problem, which I don't know if you've heard of, but these problems that I've described to you are exponentially difficult. And maybe just to give you some maths, if I've got 5 people that I need to allocate to 5 tasks, there are 5 times 4 times 3 times 2 times 1 ways of it. So there's 120 possible ways of allocating those people. If I have 15 people to allocate to jobs, I've got now over 1 trillion possible ways of allocating them. If I've got 60 people that I need to allocate to jobs, I've got now more possible combinations than there are atoms in the universe. Until we're able to figure out how to solve that problem optimally, which most people believe it's not possible, there'll always be an opportunity to try and squeeze out more value, more inefficiencies from these solutions. And Tesco's case, they're delivering to 200,000 points on the map. 200,000 factorial, it's a big number. And so how do we make money? We build solutions, we productize them, we'll make money from those products because they are valuable. I don't care also about open sourcing them if that's the best way to take them to market. But actually, in the end, my purpose is not to make money. I want to try and solve some of the problems that I see us facing over the next several decades, technological employment, maybe even the technological singularity, other problems. And I think that is not driven by people that are wanting to amass wealth and power. It's driven by people to try to use that wealth and power to try and make the world better. And that's what I'm driven by. But it doesn't mean that to say that we shouldn't make money in the interim to be able to grow that purpose.
Our future is in good hands.
Oh, I see.
The gentleman here.
Hello, Guillaume, CEO of Checkstep. I'm interested in the downside of distributed optimization, because we speak about how good it can be, but we also know, even mathematically, you can prove that some systems can't be solved efficiently without having a global view that you need, at the end of the day, a global decision maker. On to move it a little bit more into the political sphere, it's like also political system. We would hope that that democracy can be a direct democracy, but in practice, there is very few examples of successful direct democracy, where the global optimization of a country is actually dictated by a few elite.
Yeah, great question. So actually, I'm not a proponent of democracy necessarily. I'm a proponent of weighted democracy. And weighted might mean one person has to make a decision. They have all of the decision-making power. Weighted might be everybody has equal power. And the question is, how do you create an algorithm that distributes that power in an effective way? And maybe to give you an example, and I don't know if this is, I haven't thought this quite through, but imagine you're in your driverless car and you're late for a meeting. And what happens is that your AI knows you're late for this meeting. So what it does, it starts to kind of give micropayments to government to change the lights and your local cars to try and get out of the way to get you to a meeting. This is a marketplace. Now, the problem with some problems with marketplaces is if I had a huge amount of wealth, there's no amount of money that you can give me to tell me to move out of the way. And even though that might be the best decision for the whole. So that's an example of where a marketplace might fall down. Whereas if you had a communistic AI that's making decisions for the whole, it'll say, you have to move out of the way. I don't care how much wealth you have to move that way because it's important for this person to get to the meeting. And so that's an example where marketplaces maybe fall down versus a more centralized approach. I'm not an advocate of total decentralized. Well, no. I am an advocate of decentralization, but those decisions need to be weighted, and that might mean 5 people make a decision, 1 person makes a decision, everybody makes a decision.
Excellent.
Yep.
Daniel, thank you very much. I'm sorry to all the people online who asked questions. We didn't have time to get to those. I really enjoyed this. I've loved the idea that we need to create AGI to solve our optimization problems. And I also love the idea that you solved a really hard problem because you didn't know it was impossible. Thank you very much indeed.
Thank you, Calum.